Hello everyone. Today we are going to learn memory management system under operating system subject. Memory management is one of the function of operating system. Before going in detail of memory management, we will see what is memory, and once we say memory, it's nothing but a primary memory, main memory, RAM we can call it as RAM, which is having addresses, having data. Suppose we have 16 addresses, then the total memory capacity will be 64, and if 64K and if we have 20 address bus, 20 addresses, then the total capacity of main memory will be 1 MB. So likewise, if number of addresses are more, the capacity of main memory will be increases. In case of modern operating systems, your program will be divided into pages and your memory is divided into frames, because whole program cannot accommodate in your main memory, and there are number of users are there, number of programmers are there, everyone has its own size of a program, so that whole program cannot be accommodated in a computer's main memory, that is nothing but a RAM. So what will be the function of this one? The function of this is like that your program is stored on secondary memory, and this program is divided into pages. The size of a page may be 1K, 2K, 4K. Accordingly, according to the size, the memory is also divided into frames like 1K, 2K or 4K. So whenever required, that page will be bring from secondary memory into primary memory. After the work of that page is finished, the page will be again bring back onto the secondary memory. This process is called as swap in and swap out. So your program is divided into pages which is available on secondary memory, and your memory is divided into frames, and whenever we require that page will be bring from secondary memory into the primary memory, and after finishing of the work of that page will be bring back onto the secondary memory. To keep track of these pages, operating system maintains one table which is called as a PMT, page map table, and based on that page map table, that page indicates whether that page is active or not active, whether this is available in main memory or whether it is available on secondary memory. Operating system, it has got three algorithms which does this replacement of pages. The first algorithm, which is a simple one, which is called as a first in first out. uh, Under process management, we learn first come first serve, and in this the first in first out, it is called as a FIFO. The second algorithm, which is used in page replacement algorithm under memory management, and this is nothing but optimal page replacement, OPR. And the third algorithm which is used for a page replacement, and it is called as a LRU, least recently used. So how it functions? These three algorithms functions one by one we will see. The first one, and which is nothing but first in first out. We'll consider one example. Now these are the pages of a program, and suppose if we have three frames. As per FIFO, first, so this is 6, then 3, then 2. We can write separate also, but for convenience, we were writing directly here 6, 3, and 2. So it requires hits, 3 hits it will be required. So I will write it here 3. Then after page 1 will be required. So which page will be replaced? Which page will be replaced from the memory and it will be bring back onto the secondary. So being our algorithm is FIFO, which comes first. So F first in first out. So 6 will be removed. Okay. Now the next, here it is required 3, but 3 is already available. So it is not necessary to bring that page again back because it is already available. Then next it is 4. So which comes first? The third 3 comes first. So what we will do? So 1, 4 and then 2. Then 2 already it is available, so not necessary. But again 3 will be required. So this is the difference between this FIFO and LRU, which will be more powerful and which is nothing but the OPR, optimal page replacement. Now in this case again 3 will be required, but see this page number 2 comes first, so we will remove that page. 1, 4 and then 3. Then again 5 will be required, so we will remove 5, 4, 3. Now 6, so 5, 6 and 3. For 1, which page will be replaced? Because 3 comes first, that is why 3 will be removed. So 5, 6 and 1. As far as 2 is concerned, so 5 comes first, so we will remove 5. So 5, 1, 6. We will just remove, so we will remove this one, 2, 6 and 1. For the 3, again 3 required, so we will remove page. For this 3, 6 will be removed, so 2, 6 and 1. And as far as the 4 is concerned, so we will remove 2, 4, 2, 3, 1 and last one is 2, 3 and 4. So total hits required will be 5, 6, 7, 8, 9, 10, 11, 12 and 13. So we will check again. Now 6, 3, 2. So 1 will be replaced. Then 3 not necessary. Then 4 will be replaced for the 3. Then 2 already available. So again 3. So 1, 4, 3 for 5, 5, 4, 3 for 6, 5, 6 and then 3 for this 1. So 5, 6 and 1 for 2. So this is 2, 6 and 1. Okay, and for 3 again, so 2. So for this we will remove here 2, 3 and 1. So this page will be removed. So this is not necessary, the last one. So total page required will be 12. So this is a simple algorithm which we can see that the page which come first will be replaced, will be fit into the frame, So this is a very simple algorithm. Remember, in this case 12 miss are 12 hits are required. Next time we will see optimal page replacement, which is a difficult one, which is difficult to implement because it requires future knowledge. The page which will not be used for longer period of a time will be replaced. Okay, thank you.